Hello, for this lesson we're talking about adding and subtracting polynomials. Okay, for this lesson there are a lot of vocab words, so I tried to bring some of them in. We also have some ways of naming polynomials using degrees and names by naming them by the number of terms. So I wanted to bring those in for you, okay? I hope that you can read them. I know it's a little small, but we had a lot of information to fit in here, so I hope that you can read them, and I'll make sure I read them out for you in case you're having trouble. Alright, so again, we're adding and subtracting polynomials. Okay. Now, what a polynomial is it's a monomial, or the sum or difference of two or more monomials. Okay. So in order to understand a polynomial, you need to know a monomial. And a monomial is an expression that is a number, a variable, or a product of a number and one or more variables. So I'm going to write a couple examples, okay? So 3, that's a monomial, right? It is a number, okay? It could be 3a. 3a, that's a monomial, okay? Because it's a combination of a variable and a product of a number, okay? But it could have more than one variable, so it could be, 3a to the second power, it could be 3a to the second power b, okay? Those are all monomials, okay? And I wrote off the screen. There you go. Okay, 3a squared b. Okay, those are all monomials. Now, a polynomial. Okay, a polynomial. Let's go with the monomials. A polynomial is a monomial or the sum or difference of two or more monomials. So what that means, like it could be this, right? That's a monomial. Polynomial could be plus 3y because it's combining monomials, right? Remember. We're getting a couple words. Mono meaning one, poly meaning many. Okay, so it's meaning more than one. Okay, but it could be, right, a polynomial is a monomial or the sum or difference of two or more monomials. Okay. Now, it asks you sometimes, what is the degree of a polynomial? Okay, a degree of the polynomial. And it says the same value as the monomial with the greatest exponent. Okay. So the same value as the monomial with the greatest exponent. Alright. We also have the degree of a monomial, which will also, again, help us with the degree of a polynomial. And the degree of a monomial is the sum of the exponents of its variables. A non-zero constant has a degree of 0. 0 has no degree. So if we're looking through, okay, let me give you a couple examples here. 3a, okay? So since that has an exponent or a variable, a would have the exponent of 1, so its degree would be 1, okay? A constant, it says, well, that would have the degree of 0, okay? And then for something like this, let's say 4ax. Well, those would both have the exponents of 1, and so we'd combine them, and we'd say, okay, well, that has 2, all right? So that have a degree of 2. Standard form of a polynomial is when the degrees of the monomials decrease from left to right. Okay, so an example of that, number 1 here says 4y to the third power minus 2y to the second power plus 7. Okay, so the degrees decrease as it is read left from right. Number 2 is not in standard form because that's 8d plus 3d to the second power. So the monomials, or sorry, the degrees actually increase from left to right. And then we have here just 2 lists. Names using degrees. All right, if it's a constant, it has a degree of 0. Right? If it's linear, okay, that's a degree of 1. Okay, so that would be an example, 3a. That's linear because it would have a degree of 1. Okay, quadratic, degree of 2. Okay, cubic, degree of 3. And then fourth degree has the degree of 4. Okay, so and then fifth degree, sixth, and so on and so forth. Names using the number of terms. All right, you have monomial. Okay, these are all polynomials, but monomial because it has 1 term. Binomial, by 2. Right. Trinomial, try 3. Okay, so let's look through this first section. It says name each polynomial based on its degrees and the number of terms. All right, so degrees, we know that it said degree of a polynomial, the same value as the monomial with the greatest exponent, or well, really, I think we should probably say degree. Okay. Well, in this problem here, this one has a degree of 3, a degree of 2, and 7 would have a degree of 0, right? So for this one, it's going to be, based on degrees, it's going to be, well, cubic. Okay, cubic. And then we need to name it based on terms. Well, there are 1, 2, 3 terms. So it would be a trinomial. Okay, the next one, well, this one is first, right? First degree. This one would be second degree, right? This is 8d plus 3d to the second power. So since it's d, well, that would be to the first power, and this is d to the second power. So it's first and second degrees for those two monomials. So it's quadratic. If we're looking based off of degrees, quadratic. And when we look off of our list of terms, so based on terms, well, there's 1, 2 terms. So it would be a binomial. Okay, for this one, well, remember, the degree of a monomial is the sum of the exponents of its variable, right? A non-zero constant has a degree of 0, right? 0 has no degree. So this is x to the third and y to the first, right? So that's 3 plus 1. So this would be to the 4th degree. Over here we'd have to the 2nd degree, and x would just be to the 1st degree, right? So 3x to the third, y to the first, plus 5y to the second, minus x. Okay, so it's going to be the 4th. So it's 4th degree. Okay? Okay, 4th degree. And based off of the number of terms, well, there's 1, 2, 3 terms, so it is a trinomial. Alright, so for the next section, it's simplify each sum or difference, okay? And this one is really building on our understanding of combining like terms, okay, of combining like terms, alright? And for this, what you're going to want to do is you're going to want to basically create an addition problem where all of the different like terms are lined up. Okay, and let's show how we would do that. So for this, right, for this polynomial that's in parentheses, I've got 3x squared minus 5x. Okay, and then we're subtracting 3x squared plus 4x plus 2. Okay, which means I need to take away each of these values. Okay, this is where subtraction problems and addition problems are a little different. So what I would do, since it's a subtraction problem, right, make note of this, since it's a subtraction problem, I need to do the opposite of what each of the values or the signs show in front of each of these monomials. So since this is positive 3x to the second power, I need to write negative, and we need to subtract it. Okay? Since this is plus 4x, I need to write negative 4x. Notice my like terms are lining up. And then here I need to subtract 2. And if that monomial, that specific term, if there's no like term, right, you could always just treat it like it's 0 of that, right? So there's 0, and you're going to do 0 minus 2, okay? So here we go. Well, 3x to the second power minus 3x to the second power. Well, those are the exact same thing. So what will happen is that will completely cancel out. If I have 3x to the second power and I subtract 3x to the second power, that effectively annihilates, right? It gets rid of it, right? It's the inverse operation of that. So that is eliminated now. Negative 5x, right? We always take the symbols that are in front. So negative 5x minus 4x, right? We have negative 5x. We take 4 more away. I'm going to have negative 9x. I have 0x minus 2. That's going to get me to negative 2. So my answer is negative 9x minus 2. For this one, this is 3 polynomials, right? Okay. So here we go. I've got 2x squared, and it's plus 8. So guess what? I don't have the term that just has the x. So what I'm going to do is I'm actually going to let a place go. I'm going to assume I see x here, 5x here. So I'm going to leave that so I can have all of my terms in, remember, standard form of a polynomial. So I'm going to let the next one, it's addition, so it's 5x, so I would just simply write whatever sign is there. 5x, so it's positive, okay? And then minus 2, so I write negative 2. And so notice I'm matching my like terms, okay? I have this spot, and this is where I'm going to put all my x to the second power, okay, terms. This is where I put all my x terms in this line, and this is where I put all of my constants, okay? Next, it's minus, remember that the rules for minus, okay? Minus x to the second power minus 4x. So whatever is in here, I have to flip the sign. So it's going to be, instead of positive x squared, it's going to be negative x squared. And instead of negative 4x, it's going to be positive 4x. So then I need to make my equal line. All right, well, it's 2x squared minus x squared. Okay, well, this could be written as 1x squared. So 2 minus 1 is 1. So I could just do x squared plus, well, 5x plus 4x is 9x. And 8 minus 2 is positive 6. So there we go. That one is x squared plus 9x plus 6. For number 6, here we go. I've got, let's see. Well, I'm going to actually, remember, you can, commutative property of addition, you could rearrange this. And since this is a longer polynomial, I think I'm going to put that first. Okay, right? I'm going to use the commutative property of addition. I'm going to write that first. And I'm going to make sure I write it in standard form of a polynomial, which means it's descending, its powers, okay, or sorry, its degree is descending from left to right. So x to the third, that's my highest degree. X to the second, so it's plus, it's positive, x to the second. Negative 2x plus 3. And then over here I've got negative 4x to the second power, and it's positive 3. So I write those out. I'm lining up my like terms. So I end up getting, well, I'm not adding or subtracting anything to that, so it remains the same. This would be 1x squared minus 4x squared. Well, that's going to be negative 3x squared minus 2x. Right, nothing's happening to that one, so it stays the same. Plus 6. 3 plus 3 is 6. There we go. Okay, let's see, number 7. I have 4y to the 4th. Okay, I'll leave a spot for the y to the 3rd in case that shows up. I'll do y to the 2nd. Okay, and then it's minus. So remember what we have to do. I have to flip the sign. So if this is positive y to the 3rd, I need to make it negative. And then if this is negative 2, I need to make it positive. Notice I don't have anything to the first degree. Okay, there's no y, so I don't need to leave a space for it since there's no y. Okay? Because why would I do that? Ha ha ha, math humor. Okay, 4y to the 4th power minus y to the 3rd power. That would be positive y to the 2nd, right? Positive y to the 2nd plus 2. Okay? So, there we go. Adding and subtracting polynomials. A lot going on in this lesson, so good luck with it. Let me know if you have any questions.